Okay, good morning again. Hello. So we are going to continue with the review. So I did those Maclaurin series. Let's go back to my notebook. Let's see. Okay, so this is where we end up with the Maclaurin series for the sine, cosine, and exponential function. So the next one is going to be a kind of application of this power series. The application that we can have, there are some integral that's not going to be possible to find it, but we can use the power series to write, you estimate the value of the integral in some cases. Okay, so if a function is given to you and they ask you to find the integral as a power series, like a number, just tell you it's a number 5, and this is integrals. Okay, integrals as power series. So we're going to use power series to integrate. Okay, so for example, a couple of the days I do the part C. It's a 5C. You have all of them. You should study this one because we give you one of them, and you already got one on your okay worksheet. So you see this type of integral 0 to x, cosine of radical t dt. This would be impossible to find. We call it first-order integral. So what we can do, or what the calculator will do it for you, they just start with the power series of the cosine of the radical t, and then we integrate it. You know that the power series are integrable. You can integrate the power series by integrating it one, term by term. So to start with, you need a power series of a cosine of x. So you just, we talk about it, that you can have these. You can write it down in expanded form or just a sigma format. Okay, so for example, cosine x, you must know that it's going to be 1 minus x squared over 2 factorial. And that's going to be x to the 4th over 4 factorial. And this is going to be x to the 6 over 6 factorial, like something like a kind of 6 terms. You can have all of them. And you know that the general term is going to be a negative 1 to the n. And this is going to be x to the 2n over 2n factorial. Or just in sigma form. What you need is a radical t, cosine of the radical t. So you can replace the x by radical t. So that will give you the cosine of the radical t is going to be equal to the 1 minus. You replace x by radical t squared would be, just write it down so that you know what's going on. You see this is going to be the case. And then you get the radical t to the 4th, or just in general format, negative 1 to the n, and that gives radical t to the 2n over 2n factorial. So in this case, you have the cosine of the radical t, and that would be 1 minus t over 2 factorial, and then you get a t squared over 4 factorial. And in general form, it's a negative to the n, and that gives you t to the n over 2n factorial. You see, that's what. And if you want to write down in a sigma form, and this is going to be sigma of, you see the general term is a negative 1 to the n, then you have a t to the n, and this is going to be 2n factorial, n from 0 to infinity. Now you integrate it. So integral from 0 to x of the cosine of the radical t dt is going to be sigma of, just integrating the t part, is going to be negative 1 to the n over 2n factorial. They are constant. Integral of 0 to x, a t to the n dx. Integral of t to the n would be t to the n plus 1. So that gives 0 to x. Okay, cosine of the radical t dt. And here is going to be sigma of negative 1 to n over 2n factorial. Then this would be t to the n plus 1 over n plus 1 from 0 to x. Okay, just using the power rule. So integral of 0 to x cosine of the radical t dt is going to be sigma of -1 to the n, and that's going to be 2n factorial. And you have a t to the, not t, replace the t by x. So x to the n plus 1 over n plus 1. And it's true for all x. Okay, so you have to provide the power series first, okay, and then you integrate it. And you have the sine t over t e to the negative t, just study all of them. So one of them would be given to you as question in question number 5. Okay, integrals as power series. So that's a number 5, the topic that we have. The next topic is Taylor series, PV function, and we ask you to write the Taylor series, not all the terms, just something like the 5 terms. So number 6 is going to be Taylor series. And the Taylor series of a function is going to be the one. Okay, the Taylor series of a function at a is f of a plus f prime of a times x minus a plus f double prime of a, okay, over 2 factorial x minus a all squared, and you continue. The general term is the n derivative of f at a over n factorial x minus a to the n forever. Okay, this way we write it down. Say f of x is almost like, you know, that then we can prove whether it's going to be equal or that. So what we ask you is, we ask you find the Taylor series up to the degree 4. It means you have to get at the 5 terms, okay, of these function. One function would be given to, then you're going to write the Taylor series. So it's all easy. So just do one of them for you, and you can check the other one for yourself. You see, for example, this is going to be the one I do this is easy, and you can check it for yourself. I do the radical x for you. Okay, this is part B, the radical x. Okay, you have the formula. They wanted to do it at x a equal to 1. At a equal to 1. Write the formula first. You see your first term would be f of 1. Your next term is going to be f prime of 1 times x minus 1. The next term is going to be f double prime of 1 over 2 factorial x minus 1 squared. The next term is going to be f, the third derivative, okay, at 1 over 3 factorial x minus 1 to the third. They ask us for the true degree 4. So this degree 3, you need one more. Okay, it's going to be f, the fourth derivative, at 1 divided by 4 factorial, and this is going to be x minus 1 to the 4th. Okay, so you have to write up to the 4 for us. So you have your function, just find these numbers. So the function is, so yeah, f of x is equal to the radical x. You may write it down as x to the half because you want to differentiate it. F of 1 is easy. F of 1 would be radical 1, which is 1. So f of 1 is 1, the first step. Okay, then you want to find the f prime, differentiate. You're differentiating f prime of x is going to be 1/2 x to the negative half. So you want it at 1, you substitute so that you will 1/2. Because 1 to the 1/2 is going to be just 1. Okay, so that's f prime of 1. Differentiate again, f double prime, exponent times coefficient, that give me negative quarter, x to the 1 down is going to be negative 3/2. Then you find that add 1, so that give me negative quarter. Okay, then you repeat it again. The third derivative, exponent times coefficient, and negative positive, so that give it 3/8. X to the 1 down, negative 3/2 minus 1 would be negative 5/2. So you find it at 1, so that give it 3/8. Then the fourth one, so exponent times coefficient again, negative 5 times 3, 15, 15, 16. X to the negative 5/2 minus 1 would be negative 7/2. Okay, you find that at 1, you replace x by 1. So that gives you negative 15 over 60. And that's what. They may ask you to do it at 9, at 3, at 4. Then, then, for example, 2 to the negative 7/2, then you have to consider it. So you just go back, substitute, simplify to get your result. So this is the way we write it down. The series is going to be, I'll repeat it again. So I want to find what's going to be f of 1 plus f prime of 1 times x minus 1, f double prime of 1 over 2 factorial x minus 1 squared, and f of, okay, the third derivative at 1 over 3 factorial x minus 1 to the third, and the fourth one. Okay, just getting the fourth one is going on forever. That's going to be equal to f of 1 is 1 plus f prime of 1 is 1/2, so they give 1/2 times x minus 1 plus f double prime of 1 is negative quarter. It's going to be negative quarter divided by 2 factorial times x minus 1, okay, squared, plus the third derivative is 3/8, is going to be 3/8 over 3 factorial x minus 1 to the third, and plus the fourth derivative. The fourth derivative is negative 15 over 16, okay, over 4 factorial x minus 1 to the fourth, etc. You have to simplify these coefficients. So this is going to be equal to the 1 plus 1/2 x minus 1. It's going to be negative quarter. Use the reciprocal. It's going to be negative quarter times the reciprocal of 1 over 2 factorial, which is 1/2, times x minus 1 squared. This is going to be 3/8, and 1 over 3 factorial, which is 6, x minus 1 to the third, and this is going to be minus 15, 16 over 1 over 4 factorial. 1 over 4 factorial is going to be 24, x minus 1 to the fourth, etc. So simplify it so that we have 1 plus 1/2 times the x minus 1. Okay, that would be negative 1/8 x minus 1 squared. And this is going to be, you simplify it by 3, that give you 2. So 1 over 16 x minus 1 to the third. And over here, you can simplify it by 3, that give you 5, 8. So it's going to be negative 5, and 8 times 16. 8 times 6 would be 48, and 128, x minus 1 to the fourth, etc. So that give you, this is going to be the Taylor series, okay, or the first 4 terms of the Taylor series of the function f of x equal to the radical x. Okay, so it's not difficult. but you got to be careful to write it down because we give you different shortcut to find the Taylor series. But in general, you must know the Taylor series because this is the one that we may have to use in future. Okay, so that would be number 6, Taylor series. We give you one question from the Taylor series. Okay, the next one is a special, that was number 6. Number 7, a binomial series is a special Taylor series. You can do the Taylor series or use the general formula that you have. Okay, so the rest of those Taylor series, you have it on the review, so just check them. Everything's all right. You have all of them, number 14. Okay, so these are the one that you have regarding the Taylor series for the sign for all those functions. So just check it. This is the one that I did more details here for you. Okay, so that's going to be the Taylor series that we're going to have. But for the binomial series, you can use the Taylor series if you like, or there is a shortcut. We can prove it. There is a theorem. We didn't directly talk about it, but it's important to know it. Okay, it's in your book. So it's going to be binomial and binomial series. I give you the formula. You can use this formula on the test and just give us the result. Okay, you can, if you cannot remember the formula, you can bring it to the test for the binomial series. Okay, so that's it can be done by Taylor series. But this number 7, you have one on the review, binomial series. You know that the binomial expansion is a formula that you have it in algebra. You know, you have 1 plus x squared to the 3rd to the 4th. But now we are going to write down as a series. You have to use this formula for the binomial series, you see. It's a very unique formula. You can bring it to the test, so just memorize it. So the formula is, if you have 1 plus x to the k is any power you like. Okay, you see in algebra, if k is going to be an integer, you can do it. 1 plus x squared to the 3rd, to the 4th, to the 5th, you can do it. But if k is going to be a rational number, for example, if k is 1/2, it's going to be radical 1 plus x. Then you cannot use algebra. You can use the Taylor series to find it. So k equal to the 1/2, 1/3, 1/5. You can use the Taylor series. Or you can use this formula, a shortcut. Okay, the shortcut is, this is going to be a series in this form. And the terms are going to be 1 plus k times x is going to be plus k times, it's going to be a factorial form. It's a little bit complicated if you're not complicated. Maybe you may be confused, but you better write the terms. K times k minus 1 over 2 factorial x squared. It's also using a statistic. The next term is going to be k times k minus 1 times k minus 2, okay, over 3 factorials. Then you get x to the 3rd, and you can continue forever. You see, this is just the first power k, the second power up to the k minus 1, the third power up to the k minus 2. They ask you to write it through the degree 4. So the next one, I write down here, this is going to be k times k minus 1 times k minus 2, okay, times k minus 3. And this is going to be over 4 factorial. X to the 4th, and you can go on forever. This is going to be a series, and this is like a geometric series. The radius of convergence of this series is 1. Okay, so you can write it down, and can have in different formats. Okay, so this is going to be where k is this is going to be true when k is any number, any rational number. Rational number, if it's going to be an integer like 2, 3, it's going to be stopped. You see 1 plus x squared is 1 plus 2x plus x squared. You see 1 plus, if you have it in algebra, just for your information, you see in algebra, if you have 1 plus x all squared, it's going to be a square of the first, twice of the first times second, and the square of the second one. You see, you end up here. But if you have 1 plus x to the third, again, is going to be, it's going to be 1 plus 3x plus 3x squared and the x cubed. You see, you end up here. So you can go on forever. This is where the powers are positive integer. But if the power is going to be 1/2, 1/3, then you cannot do this. You have to go through this formula. Okay? So for the positive integer, it's just a polynomial. But for the rational number, it's going to be a power series. And this is going to be that power series. Okay? So you know the formula, we give you one of them, just substitute and give us the result right away. Okay? So for example, part 1 is going to be, just give you one easy one because we want to, not difficult, but don't miss it. You can even bring this formula for yourself. It's available and do the substitution. You want to make sure that you understand this series. Okay, the part 1 is, so you have all the solution. You see, this is the solution of this question that already posted for you. You have all of them. Okay, so the part 1 is f of x equal to 1 plus x. Again, if you want to take more courses in mathematics or sometimes in applications, you need this type of ideas. You see, you want to write this one as a power series. You can use the Taylor series if you like. Find f of 0, f prime of 0, f double prime of 0. It's the same thing, but this is much easier. Okay, so you realize that in this case, you see your k is what? K is 4/3. So write the formula for k equal to 4/3, and then you're done. You have to simplify that, of course. Okay, so there you are. 1 plus x to the 4/3 equal to, I just use the formula, replace by k by 4/3, 4/3 x plus, on the top is going to be 4/3 times the 4/3 minus 1 divided by 2 factorial x squared plus, you repeat it, 4/3 minus 1, 4/3 minus 2 over 3 factorial x to the third. They ask for up to the 4th power plus 1 more 4/3 minus 1, 4/3 minus 2, 4/3 minus 3 divided by 4 factorial x to the 4th, the radius of convergence of 1. Simplify this coefficient and you're done. That's all we need you to do for us. Okay, again, we want to make sure that you remember this famous series. Okay, so there you are. This is the solution. 1 plus x, or the final part, is going to be 1 plus 4/3 x. Patiently simplify these fractions. Just on the top, this is a 4/3. Is a 4/3 minus 1. It's like 4 minus 3, that gives 1/3. Times that by 1/3 over the 2 factorial, which is 2 x squared, plus on the top is a 4/3 times 1/3 times 4/3 minus 2 is like 4 minus 6 on the top. So that gives a negative 2/3. 3 factorial is 6, and that's x cubed. Plus, you continue here, you have the 4/3. Okay, you have the 4/3 1/3, negative 2/3. The last one would be like 4 minus 9, which is a negative 5/3, divided by 4 factorial. Okay, 4 factorial is going to be 24, x to the 4th, etc. So go on, it's going to be 1 plus 4/3 x. On the top, you simplify that, give you 4, 9. So it's going to be plus 4, 9 multiplied by reciprocal of the 2, which is 1/2 of the x squared. The next one is going to be negative. The top would be 4 times 2, 8. 8 over 27 times it by the reciprocal of the 6, which is 1/6, because it's a division. Okay, x to the 3rd. The next one, negative would be positive, so it's going to be plus. The top, 4 times 2, 8. 8 times 5, 40. Okay, and this is going to be 3 to the 4th, 81. 81 x to the 4th. That's it. So it's going to be 1 plus 4/3 of x. Okay, you simplify these two, plus 2, 9 of x squared minus, and we simplify these two by 2, that give you 3, that give you 4, so that give you 4 on the top. And this is going to be 81 x to the 3rd plus 40 over 81 x to the 4th, and you're done. Okay, so this is going to be, of course, the radius of convergence is 1. That's going to be binomial series. Okay, it's a kind of, especially it's the Taylor series or the Maclaurin series. So I did the other one by differentiating. You can do this one, by differentiating again. You see f of 0 would be 1. You differentiated, that give you 4/3, 1 plus x to the negative, okay, to the negative 1/3. You substitute 4/3. So it's the same thing. But this formula make it easier for us. Okay, so we give you one of them, binomial series. You get this one, so to look at the solution that we have. So that's a number 7. Okay, number 8, it's just some identities that we prefer something like using the Maclaurin series. Okay, so if we give you something like number 8, we give you the one in terms of the, okay, e to the x sine x or cosine x. So that would like number 10. I explain the number 10 for you. We give you a hint. You cannot do it right away, but they give you a hint that you see number 10. The hint is going to be, we ask you to apply. You say this is going to be the application. We say we ask you to apply. We give you the hint. Apply the power series or Maclaurin series. Power series of, let's say, e to the x, cosine x, or sine x. There's going to be only of these 3. Okay, to find the sum of each series. Sum of each series. So you have to write these series, replace x by a number that give you the one that you are interested in. You see, look at this one. You have 3 nice ones in that worksheet that I gave you. You see, look at the series that you have. The series is pi minus pi to the 3rd over 3 factorial. Then pi to the 5th over 5 factorial. Pi factorial minus pi to the 7 over 7 factorial. See, if you want to do this one, you look at the powers here. The powers are odd. You get the, okay, you get the odd power when you write the power series of the power series of the sine, you get the even power if you get a power series of the cosine, and you get any power when it's e to the x. So since it's odd, you are going to say, oh, note that in the case of the sine x, sine x, you have x minus, x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the 7 factorial, etc. That's the x. And you know that this is true for all x, for all x. So replace x by a number that give you this series. It's clear, you see, compare them together, x equal to pi. Because this is x cubed, pi cubed, x to the fifth, pi to the fifth. So we're just replacing x by 5. So if you put x equal to pi, substitute in both parts, going to be sine of pi equal to the pi minus pi cubed over 3 factorial plus pi to the fifth over 5 factorial, pi to the 7 over 7 factorial. See, that's what. But the sign of the pi is 0. See, bad. Sine of pi is 0. So this means this is 0. So this that the sum of that series, you see, that's a given one. Pi to the fifth over 5 factorial, pi to the 7 over 7 factorial is simply 0. And then you're done. Very nice method, but you have to give you are going to give a hint what series you can use to get this. Okay, so this is the first part. And the second part B, you have 5 plus 25, 2 factorial. Then you have 125, 3 factorial. Okay, 3 factorial, and you continue, we get 625, 4 factorial. Again, you check to see, you see this is 5, this is 25, 5 is squared. It's 125, 5 to the third, 5 to the fourth. So you have all the powers. And you have, 1 factorial, 2 factorial, 3, 4. So this means it's very much like the exponential e to the x series. So you realize that you have to use this series. Say, oh, note that e to the x is 1 plus x squared over 2 factorial, x cubed over 3 factorial. And you continue. This is again true for all x, all x. You compare it to see what is going to be your x. You see, if you compare them together, you can compare the x with the 5. 2 factorial, x squared is 25. So x is 5. X cubed is 125. So x is 5. So you realize that if you put x equal to the 5 here, x equal to the 5, you're going to have e to the fifth equal to the 1 plus 5, 25 over 2 factorial, 125 over 3 factorial, and the next one's going to be 625 over 4 factorial forever. But the one that you're going to be interested in just 5 plus. So what you do is, you see this one. So subtract the 1. So that gives you e to the fifth minus 1 is equal to the sum of the series that you are interested in. 25 over 2 factorial, 125 over 3 factorial, 625 over 4 factorial, etc. So the sum of your series is e to the fifth minus 1. Okay, these are kind of nice application of the of the power series, but the series must be a known one. It's not the case that if you give me any sum. So they give you a hint for the first part. Okay, they give you a hint, then you have to apply that hint, to get these numbers. You can have a look at the one that we did for number 8, but we give you something, and the hint would be given to. Okay, number 10. You can look at the number 9 yourself. Is Maclaurin series, like the application that I talk about it. We write the power series of those terms and take the limits. So that will take us to so that's a power series part. Okay, power series part. Now 4 questions or 5 questions on the polar coordinates. Let's start with those polar coordinates. So again, you have the one, you see this is the one that I did for you on your find out. You got it on your review. Okay, I did it for the sine, cosine. This is number 9. You can read that one yourself. That we just using the power series to find these limits. So I go to the, okay, so I characterize for you that 5 problems on the polar coordinates that we have. Okay, so the first one is going to be tangent line, the slope of a tangent line, number 11. So that's going to be the slope of a tangent line. Tangent line in polar form. Polar form. Okay, we give you the formula for these. Remember, the idea is start from here that your x is going to be r cosine of the data, and the y is r sine of the data. Okay, that's the x and the y. R is going to be a function of, okay, where r is f of theta, the function of theta. So we have the formula that you memorize it. So the slope m is going to be dy dx. D by dx is going to be the formula, and we prove it for you that d by dx, you differentiate. So this is like derivative of the y respect to the data, and derivative of the x respect to the data. Okay, so we just use the product rule, give you the derivative of this one. You see that was the top one was say derivative of the first times second, that was a dr d data times the sine of the data, and the second part is the derivative of the second times first is going to be r times the cosine of the data. The bottom one, we differentiate the x, use the product rule, derivative of the first times second, dr d data, okay, cosine of the data. Derivative of the second times first, it's going to be minus, okay, minus r sine of the data. That's your formula for this slope. Okay, we can call this one f prime of data if you like it, but make sure you have the proper formula. So the slope is this one. If you have the function like this one, f prime of data, sine of the data, plus f of data times cosine of the data, or just r. And this is going to be f prime of the data, cosine of the data. It's very similar, the formula. You see the top is sine cosine, the bottom one is cosine sine. The coefficients are the same. So this is the formula that we need for this problem. Okay, one function would be given to, and we ask you to find this slope at one point. Okay, we give you one. But just do one of them and you have the solution on both of them. So the function is r equal to the 1 plus sine of the data, and you want to find it at data equal to the pi half. That's it. This is your formula. You find the, you can call it R if you want to use this formula, or call it f of theta if you want to use the second one. Okay, I just call it f of theta, but it's up to you. So this is going to be f of theta is 1 plus sine of the theta. I find f prime, differentiated derivative of 1 is 0, derivative of sine is cosine. Cosine of that. That's it. Substitute and then find it at theta equal to the pi half. So m is equal to, you can find them first, then substitute, just do it right away. Okay, m, f prime of theta, this is going to be f prime, cosine of theta. Okay, cosine of theta times sine of theta plus f of theta, which is r, 1 plus sine of theta times cosine of the theta, and you divide by f prime of theta, which is cosine of the theta, times cosine of the theta minus f of theta, which is your function, 1 plus sine of theta, okay, times the sine. That's it. Substitute, simplify. Even you can simplify it first, then go back, substitute. It's up to you what you want to do, okay? So the data is equal to the pi half. If you like, as I told you, you can simplify it further, substitute, or just quickly substitute. You can multiply this one, let's multiply it, but you don't have to. So it's a cosine of theta times sine of theta, and this is going to be cosine of theta plus sine of theta, cosine of theta. Down the bottom is going to be cosine square of the theta, and you distributed sine of theta. There's a negative sign here, minus sine of theta. Okay, sine square. That's it. The top is now these two will be 2. Or again, I'll tell you, you can substitute, then simplify. So that gives you 2 cosine of the theta, sine of the theta, plus cosine of the theta. The bottom one, nothing to do, we simplify. So now substitute theta equal to the pi half. So m would be, it's a 2 cosine of the pi half, sine of the pi half, plus cosine of the pi half. The bottom one is cosine of the pi half squared, minus sine of the pi half, minus the sine of the pi half squared. You know that the cosine of the pi half is 0, sine is 1. So cosine is 0, that would be 0. Oh, that would be 0 too. So the top would be 0. So this would be 0. This is 1, and this is 1. So m is equal to the 0 on the top. 0 minus 1 minus 1. It will be 0 over negative 2, which is 0. So the slope would be 0. And then you're done. Okay, not a big deal really to get this number done. Okay, again, you have a solution, and this is the solution that we have, and this is the solution for the second part. And you have one in that work, worksheet that I give you. So this is how you handle the problem of the, make sure you have a proper formula. This is it. You need that formula. And one of them would be given to you. Okay, so that's our question number 1 on the polar form. Question number 2 on the polar form is the arc length. Again, it's not difficult. The integral need integral of a sine square and a cosine square most of the time. So number 12, arc length. Okay, arc length in polar form. okay, in polar form. You need to know the formula, otherwise it's a straightforward problem. And so the polar form formula, arc length L is equal to the integral from alpha to beta, and the two angle would be given to you, and the square root of two versions of this formula, whatever you like. One version is this one, dr d theta all squared plus r squared d theta. That's the formula. This is where r is f of theta, the given function. Okay, so dr d theta would be derivative, or some people like it in this form. So alpha to beta, the square root of f prime of theta all squared plus f of theta all squared. The function is squared and this derivative. Okay, either one would be fine. First one is easier, just use it. Okay, so that's it. So in this case, r is equal to 7 times cosine of the data, and the data is between 0 and 3/4. You have the formula, substitute. You need to find the dr d theta first, derivative. So dr d theta. 7 is a number, you have a cosine negative sign, so negative 7 sine of the data. That's it. Go back a substitute to get these numbers. We can simplify it first and go to the inside that radical. That will help you. Okay, so form what is dr d theta all squared plus r squared is going to be negative 7 sine of the data all squared. Oh, yes, that's a derivative, plus r squared 7 cosine of the data all squared. Okay, square of the first one would be 49 sine squared, and this is going to be 49 cosine squared. If you factor out the 49, the leftover is 1 sine squared plus cosine squared. Okay, you know that this is equal to 1, so that gives 49. That's it. So the expression inside the radical is 49. So L is equal to the integral from 0 to 3/4 radical 49 d theta. Radical 49 would be 7. So 0 to 3/4 7 d theta. Integrated is going to be 7 d theta plus 0 to 3/4. So it's going to be 7 times 3/4 minus 0, minus 7 times 0. So this would be 0, 7 times 3, 21, 21/4. So the arc length is going to be 21/4. Okay, that would be the arc length. I have a couple of more, then I do one more module later. The one with the interesting one is going to be the one with this cardiac. Let's see which number is this one. Yes, the number 14 is an interesting one. Of course, you have the solution of all of them here. So I do number 14 as well to explain it because of the okay, because of the just the term involve. Just make sure you know it. The length of the cardiac is one of the famous problem. So when you're dealing with the arc length, because I do one more for you, and you have quite a lot here. So I do number 14. 14 and 15 are the same, but in 14, you have to do a little bit of algebra to get it. So I explain this one too. You want to find the arc length of this function. R is equal to cosine squared, okay, of that I have. Okay, and they ask you to graph it and then find your arc length. The point is you have to use the double angle formula to write this one. With the double angle formula, you see, note that the other one is directly given, but this one, cosine square of the data I have, remember, we reduce the power, but we double the angle. It's going to be 1 minus cosine of the double angle. That's theta half, you double it to get theta over 2. Okay, so it's going to be plus because of the cosine. So it's going to be 1/2 plus 1/2 of the cosine of the data. So it's a cardioid. It's a cardioid. Okay, you can graph it easily. You just need a couple of numbers to see how it's going to be, pointed to the right or to the left. So just say a couple of nice numbers would help you. That's a data, and that's R. If you put R data equal to the 0, cosine of the 0 is 1. So that gives you 1/2 plus 1/2, which is 1. The other nice number is pi half always. Cosine of the pi half is 0, so that gives 1/2 plus 0, which is a 1/2. And if you put the pi, cosine of pi is a -1, so that 1/2 minus 1/2 equal to the 0. That gives 1/2 of the cardioid, and that would be enough to graph it. Because you want to know what's just the direction is. V 0, 1, that's 1. Pi half, 1/2. So that's going to be pi half, okay, 1/2. Then the 0. So that gives 1 portion of the, okay, of the cardioid. And since it's symmetric, you can get the other part yourself. So that's going to be the one. Okay, so you get the first one from 0 to pi. You see from 0 to pi, and then the second part. Okay, so it's symmetric. So if you want to find the arc length, the data is going to be between 0 and 2 pi. As you go around, so the arc length is going to be integral from 0 to 2 pi. The formula that we have, dr d data all squared plus r squared. Since it's symmetric, you see the top at the bottom. You can find the top from 0 to pi and then multiply by 2. So you have a choice. You can do it directly as well. So it's going to be 2 integral from 0 to pi. dr d theta all squared plus r squared. That's a choice, but you better use it. So you better simplify it first, as I did it for the other one, and eventually integrate it. So this is it. Your function is r equal to the 1/2 plus 1/2 of the cosine. Differentiate it. dr d data. There's a 1/2 0. Have a cosine minus negative sign, so 1/2 of the sine of the data. Okay. So from this one. So what's a dr? Do it step by step. A square plus r squared. So that gives a -1/2 of the sine of theta, all squared. R squared is 1/2 plus 1/2 of the cosine of the data, all squared. Patiently square it, simplify. It would be simplified, but carefully do it. It's going to be a quarter. All the format of the polar coordinate, polar equations Most of them are going to be simplified. So if it's going to be getting something complicated, probably you made a mistake. Okay, a square of the first one would be a quarter. 2 times first times second, so it's going to be plus 2 times 1/2 times 1/2 of the cosine, and plus the square of a second one, which is a quarter of the cosine square. Okay, so you have a quarter, you see you have a quarter of a sine squared and a quarter of a cosine squared. If you factor out the quarter, so that gives you sine squared plus cosine squared, which is 1. So that would be 1. Then you get a quarter here plus a quarter. 2 and 2 would simplify, so that give you, okay, plus, you get, okay, so these two would cancel out. You get a 1/2 of the cosine. Just checking. Just make sure I didn't miss anything. So it's going to be, oh, I missed something. Sine squared plus cosine squared would be 1. So this is a quarter. We factor out the quarter, so that would be a quarter times sine squared plus cosine squared. Now it would be fine. So that would be 1/2 cosine of the data, because these two would cancel out. So a quarter and a quarter would be half. So I get back to the original formula. It's always the case for the guardian. It's going to be nicely simplified. Okay, so I put out the quarter, so that gives me sine squared plus cosine squared, which is 1. So the leftover quarter. I have a quarter here. So twice, 2 times first times second, 2 and a 2 simplify, 1/2 of the cosine. Okay, so this is going to be the case. Now, you see this is going to be like the original one that we did, which is 1 plus cosine of the theta over 2. Since you want to take the square root, you remember that this is going to be cosine square of the theta half again, original one. You see, that's the point about guardian. Otherwise, because you have to take the square root, you see, because you have to take the square root to integrate it. So be careful of these tricks. So that's it. So the arc length is twice of the integral from 0 to pi, the square root of cosine square of the theta half d theta, which simply would be 0 to pi. You take the square root, it's positive, nothing to worry about. Cosine of the theta half d theta. See, easy integral. And you know that this integral is going to be 2 times the integral of a cosine is sine. Sine of the theta half, you have to divide it by u prime, which is 1/2, and evaluate it from 0 to pi. Okay, integral of cosine is sine, but u prime is 1/2, you divide. So use the reciprocal for this one. Okay, so that was, I didn't miss anything here. That was a 2. So we have the 2 here. Okay, that's a 2. So it's going to be divided by 1/2. So this gives me something like 4. Okay, it's going to be something like the 4 sine of the theta half from 0 to pi. Okay, if you substitute sine of the pi half would be 1. Sine of the 0 is 0. So the result would be 4. So the arc length of this guardian is equal to 4. Okay, so the guardian of the arc length of the guardian is going to be a little bit tricky. And just make sure that you get it right. So that's the arc length. Okay, so that's the second problem on the polar form. The next one, getting the graph of these functions, you can just use your calculator if you like, or the one that I did for you. You don't have to use these. Just use this, this graphing table. You can find these on internet for the graphing a polar coordinate. If you need these measurements, just check on internet. You see the copy, and you just need a table to do it. You can use your calculator to take it, to estimate it, and then graph it. Okay, so be one of them. Just get practice, make sure that you have it. Okay, it's going to be only one, something like the cardiac or those pedals. Okay, roses, you know, just one of them will be given to you. Not a big deal for that one. Okay, so this is going to be, so that was number 14 that I talk about it. So for graphing one, you just check the one that we have. So we give you one of them, you know, sketch the graph of the, and just write it down so that you know that you have to read it. Sketch the, okay, the curve in polar form, in polar form. You can use your calculator if you don't mind, you know, but you have to graph it for us. So check this one. So that will take us to the area problem. It's going to be easy problem, like number, that was a 13. I talk about the 14, 15, the arc length of the cardiac again. So 15 is the same as I did. 15, 16, you get quite a lot of arc length. But the next topic is going to be number 17. Okay, find the area. Find the area and there the curve. The curve in polar form. It's a very easy question. And we already give you the formula. The area under the curve is going to be A equal to, okay, it's going to be A equal to the integral from alpha to beta. But you must remember the formula, 1/2 of the, okay, 1/2 of the R squared, or F of data squared. These are going to be the ones that we're going to use. We bring that the questions related to this one. Just make sure you get the correct formula on this. It's the question of the, yes, that's the question of the area that we have. Okay, so it's a 1/2 of the R squared and D data. You know, R squared is just, or if you like, A is equal to the integral from alpha to beta, 1/2 of F of data squared. Okay, we proved it for you that because of the segment of the circle, you arrive at this formula. So the function and the range of the data would be given to you, just integrate it. So in number 17, the function is R equal to the square root of the sine of the data. And you want to get it between, okay, between 0 and 2/3. Simply substitute, get the result. Okay, and you have all these solutions here. These are the area type that you have it. Okay, so this is it. A is equal to integral from 0 to 2/3, 1/2 of the function, radical sine of the data, but remember a square, don't miss it, it's a square. In the xy coordinate, there is no square, you just integrate the function, remember? You integrate f of x dx, but in the polar form, the formula is different. So you just square it, 0 to 2/3, that give 1/2 sine of the data, d data, that's it. Put out the 1/2, integral from 0 to 2/3, sine of the data, d data. Integral of a sine is negative cosine, negative 1/2 cosine of the data. Okay, to be evaluated from 0 to 2/3. Substitute is a negative 1/2 cosine of the 2/3 minus negative 1/2 cosine of the 0. Okay, that's it. So the cosine of the 2 pi third is 120. The cosine is the same as the cosine of the 60 degrees, is a negative half. So it's going to be, okay, this is going to be negative half times a negative half. And the cosine of the 0 is 1. So that you plus half. So you have okay, negative half would be a quarter plus 1/2, which is going to be 3/4. So the area would be 3/4. And then you're done. Okay, so the area of problem is going to be easy problem. But sometimes the tricky one is going to be the one like the area of those pedals that we have. Okay, so let's see. We have a number 19. I explained this one for you. Number 19. Again, you have all of them here. Okay, and this is the number 19. I just want to make sure you understand this, okay, because you have to have the limit of integration yourself. That would be important, okay. So in number 19, they ask to find the area of the curve. Find the area of the curve. The curve is r equal to the sine of 3 theta. Okay, that's the roses, and you know that when the coefficient is odd, so this is 3, you are going to have 3 petals. So if you find the area of one of those petals, then you can multiply it by 3 to get the numbers. Okay, so that's the idea of these type of problems. You have to know the graph. You see that's going to be the one. So you have 3 petals. That's going to be 1, and this is going to be 2, and this is going to be 3. So you can find the area of one of these and you multiply by 3. Or you can divide this part into 2 parts. You see, 2 parts. This is going to be the one. You see, from 0 to whatever number is this. And then you multiply by, okay, multiply by 6. To find out where is going to be this part, you see, just find the period of this function. You see the period is a 2 pi. Okay, it's going to be 2 pi over 3. 2 pi third, if you like. Let's maybe do it in tricks. Okay, that's going to be the period of the function, and which is going to be 2 pi third, 120. Then when we graph it in the tricks, okay, we divide by 4 for the sine and the cosine. If you divide this one by 4, so that gives you 2 pi third times it by a quarter. So the top would be 2 pi 12, which is a pi 6. So each of these portions is going to be the pi 6. So what you can do is, that's the important part is here. So this is going to be the pi 6. So what you can do is, you can find the area of the half of the pedal, and then you multiply by 6. So the area is going to be 6 times integral from 0 to pi 6, 1/2 of the r squared d theta. So you've got to be careful because you have to know that limit of integration to do it. Okay, so if you graph this one as a function in the trigonometric function, the domain is going to be 2 pi third. The period we usually divide by 4, and this function would be repeated itself after, in these 4 parts that you're going to have for the sine. See the sine function, this is it. This is going to be a sine. We divide into 4 parts. Okay, in the first part, you go up, down. You see, this is going to be the sine function. It's going to be, this is the first point that you get it, okay? And it's going to be the maximum, the minimum in the meantime to get those intercepts. So that's a pi 6 that you got over here. That's why we divide by 4. Now you substitute and integrate. Okay, so this is it. A is equal to the 6. Integral from 0 to pi 6. 1/2 of the r squared, which is going to be sine the square of the 3 theta d theta. You have to use the half angle. Okay, or the double angle formula. You pull out the 1/2. These two would simplify, so that give you 3, 0 to pi 6, sine square of the 3 theta d theta. So you use the reducing formula, 0 to pi 6, so that give 1 minus cosine of, you double the angle. The angle would be 6 theta over 2 d theta. Easily integrate, because you can pull out this 1/2 again, so that give you 3/2. Integral from 0 to pi 6. And that's a 1 minus cosine of the 6 theta. So it's going to be 3/2. Integral of 1 is theta. Integral of cosine is sine. It's going to be minus sine of 6 theta. But you have to divide it by 6 to be evaluated from 0 to pi 6. If you substitute, simplify it, you get a pi 4. You see, it's going to be 3/2. And this is pi 6 minus the sine of, if you replace the data by pi 6 times 6 would be pi. And the sine of the pi is 0. And the rest are going to be 0. So that gives you 3 pi 12, which is a pi 4. So the area under this curve is going to be pi 4. Okay, so the integral is not difficult. Setting up the integral is going to be important. And it's unavoidable that you have to use the square of the binomial. So that's area under one curve. The last question is going to be area between two curves. You have two curves, you find the area of each and you subtract it, like in calculus 1. So I give you 1 from here. And again, you have all these solutions. So what's going to be the area between two curves? Okay, that's going to be our last topic. And you have a couple of them over here. For example, number 20. You know, we are not going to give anything complicated. You have one on that worksheet, the area between two curves, like in calculus 1, in polar form. Polar form. So we have two curves, so the area is going to be, we find the area of each and we just subtract it, okay, to get the area between two curves. Just bring the one that I posted for you. And this is, I did that one too, bad, okay. Going to try it to show you. You see that's going to be the area between two curves. So the curves are going to be, so it's going to be something like 1/2 integral from alpha to beta, two curves. You can call the first one f of theta all squared minus g of theta all squared. Find the area of each curves and then the curve and you subtract it. So, for example, in this number 20, what you have is you have two circles, two curves. You have one of them is r equal to the 8 is a little bit of algebra involved. This is one of them. And the other one is r equal to the 4. Both of them are circles. So both of them are going to be circles. Okay, just check to see where did I put these numbers. Okay. These are going to be, I don't have it, that doesn't matter. Okay, so what they ask you to do is find the area of the region that lies inside the first curve and outside the other one. You have to graph it a little bit, or you can do it right away without any graphing. But first thing to do, you have to find the intercept, like in calculus 1 for the ordinary function. You have to intersect these two to find out what is the alpha and the beta is. Okay, so the solution is going to be, so put them inside of the one system of the equation. Okay, and that's going to be r equal to 4. So let them to be equal to each other. It's going to be 8 sine of the theta equal to 4. So the sine of the theta is equal to the 4 over 8, which is 1/2. And the 1/2, you know that the 1/2 is going to be sine of the 30 degrees. So that gives you sine of the pi 6. Okay. So it is going to be sine is positive. So it's going to be in the first quadrant and the second one. And in the second one is 150 degrees. Okay, so basically this is what you're going to do. You have to, you have to integrate it, integrate that the difference that we talk about it in this, in this format. Even if you don't graph it, it can be done quickly. Just check to see if I gave you this one on that review or not. Okay, I have to check. Just make sure you already got it. Okay, you have a similar one probably. You see that's going to be the one. So your data is going to be between the pi 6 and the 5 pi 6. You can integrate the difference over here and get your result, or if you get a time, or just use a brief calculator to get an idea of what's going on. Otherwise, you just find the difference. The only thing is this must be positive. If you don't graph it and you get the result, if the result is going to be negative, you just switch it. But they give you the idea of find the area of the region that lies inside the first curve and outside the second. Look, see, this is the one. This is a circle, r equal to 4. So r equal to 4. See, that's going to be 1, 2, 3, 4. Just to get a better understanding. Otherwise, I can do it right away. 1, 2, 3, 4, and that's 1, 2, 3, 4. So 1, 2, 3, 4. So if you graph the first one, so it's a kind of the first one that I got over here is going to be this one. Okay, and if we do the second one that we got over here, r equal to the 8 data, this is going to be a bigger one. So your bigger one is going to be, because this is 8, you need just a couple of terms to get this one done, because when the data is 0, r would be, when the data is 0, and that give you r equal to the 0. Okay, so that would be 0 here. But if the data is equal to the pi half, so the pi half that give you 8. So this is going to be kind of this is 4, 5, 6, 7, 8. If you graph this one, 8, 8, 8, So the origin is going to be, you see, it's going to be the one, roughly. Okay. This is going to be a rough case of this one. Okay. And so the one that they ask for it is, this is going to be the one. They say find the area that lies inside the first curve. Okay, inside the first one. This is going to be the first one, inside the first one, and outside the other one. Okay, outside the second curve. It's going to be something like, I have to graph it more carefully, but it's going to be something like this. Okay, so the intersection point that we got is these 2 points that we have here. Okay, and the integral is going to be, you see the A is, we can check it with your graphing with calculator, but we don't need it really. It's going to be integral from pi 6 to 5 pi 6. Okay, integral. I should have this one, or I've done it for you somewhere. Check that on it. Okay, so we find the integral of a difference. Okay, so this is it. The first function is 8 sine of the theta squared minus the second function is going to be 4 squared. Then everything d theta. Okay, the difference. Even if you don't graph it, you can find this one right away. Okay, so you have to square it and simplify it, then integrate it. It's going to be 1/2 integral from pi 6 to 5 pi 6. So that would be 64 sine square of the theta. And this is going to be 16. Okay, 16. And this is d theta. Then you have to integrate it, nothing else. So we can simplify that a little bit. Okay, if you pull out the 16, then the 1/2 can be simplified. So it's going to be 16/2 integral from pi 6 to 5 pi 6. Okay, so that gives you 4 sine square of the theta minus 1 d theta. Then this would give you 8. So that gives you 8 integral from pi 6 to 5 pi 6. And you have a 4 sine square of the theta minus 1. So to integrate it, you have to replace the sine square by the double angle formula. It's going to be 8 integral of pi 6 to 5 pi 6. And that's a 4 times 1 minus cosine of the double angle divided by 2. That's a minus 1. Then d theta. 4 and 2, you can simplify it. So that gives you 8. You can integrate it separately if you like, pi 6 and 5 pi 6. Okay, so that gives you something like 2 times. Okay, it's going to be 2 times 1 minus cosine of the 2 theta minus 1. Then d theta. Okay, you know, if you multiply this one, simplify it. So that gives you 8 integral from pi 6 to the 5 pi 6. If you multiply 2 and the 1, that gives you 1 again. Minus 2 cosine of the 2 theta d theta. Okay, sometimes you need to simplify it carefully to get this result. Now the integral is going to be straightforward. Integral of 1 is going to be theta. Integral of a cosine would be sine. 2 sine of the 2 theta, of course, divided by 2, and to be evaluated from pi 6 to 5 pi 6. Okay, so this is going to be 8, a bracket. You substitute for the data, that give you 5 pi 6. Okay, minus, you simplify this. Sine of 5 by 6 times 2, that give 5 by third. Okay, then it's going to be minus in bracket. So that give you pi 6. And it's going to be minus sine of 2 theta, that give you 2 by 6, which is going to be pi third. Okay, then you substitute this result. You have to use your calculator to get the actual numbers. Okay, because this is going to be just 5 by 6. Integral of 5 by third. Okay, it's going to be 300s. Okay, 300s, and this is going to be, it's going to be plus radical 3/2. And this is going to be minus by 6. And this is going to be plus the sine of the pi third. 60 degrees will be radical 3/2. Okay, then you simplify these numbers and then you're done. So 5 by 6 and the pi 6 would be 4 by 6. So going to be 8 times 4 by 6. And radical 3/2 and the radical 3/2 would be radical 3. So just multiply them together, give you the final answer, or just use your calculator. Okay. So basically this is going to be 32/6. We simplify that, give you 16 pi third plus radical 3. So that gives you the area between that two curves. It takes a little bit time, but it's not bad. But you have to find that intersection first. We have a couple of them on the review that I gave you, but we try to give you something easy. It's not difficult, just integrations. Be careful. Okay, so this is all the topics that we need to know. We try to give you a shorter one on the test. Okay, but the topic's going to be the same, so that we're able to do it for that in the time that we have. So we are not going to give, of course, a 16 question would be too many. But from these topics, something like the one that you got, something like 13 maybe question would be given to you. Or if we give you 14, you can answer 13 questions. Okay, so that's it. Read this one, study this one first. You have all the solution that I did here. You can double check it with your answer sheet that we have. Okay, and then do that the worksheet that I gave you, so that give an idea of what's going to be on the final. Okay, otherwise have a good one. Take care and see you on Tuesday as usual for that test. Okay, so you must be on Zoom. You know that. I will remind you by posting the time, the starting time and the ending time. Just make sure you are going to be on Zoom and on time. Okay, we give you enough time to finish it. Don't worry about that. Okay, have a good one. Take care and watch this and do the worksheet. Let me know if you have any question. You can email me.